All right, welcome everybody. Let's see what you got for this problem. Let's see. So, number 2. It says the radius of a circle is decreasing at a constant rate of 6 minutes per minute. 6 meters per minute. At the instant when the radius of the circle is 9 meters, what is the rate of change of the area? Round your answer to 3 decimal places. Okie dokie. So, let's look at the first part. It's saying the radius of a circle. What do you know? We know that the area of a circle is equal to pi r squared. Okay. What are you given? Let's look at the first sentence. It's saying the radius. Okay, the second you see the word radius, let's think of r. Now it's saying of a circle is decreasing at a constant rate of 6 meters per minute. So then here we could say that r is equal to negative 6, not r, dr dt is equal to negative 6 meters per minute. Okay. Now let's look at the next part. It's saying at the instant when the radius of the circle is 9 meters, so we know that when r is equal to 9 meters, what is the rate of change of the area? So here, where's another color? Okay, it's saying what is the rate of change for the area? And we know this is what we want to find. So this should be dr, am I going crazy? Wait, the instant when the radius, what is the rate of change of the area? Okay, so dA dt equals question mark. Okay, and that's what we want to find. Now, visually, what is happening here? It's saying, same idea as the previous question. You have a circle, and it's the constant rate, the radius of the circle. So you know that every second, whatever the radius is originally, you know that the radius is decreasing. And notice if the radius is decreasing, then your circles have to be decreasing as well. Okay? So that's visually what's happening. What are we looking to find? It's saying, what is the rate of change of the area? You know every second that the radius is decreasing by 6 meters. Okay? And notice this is weird because if it decreases by 6 meters, at 1 second, what's the next? So if imagine this is 0 seconds, then at 1 second it should be like 3 meters, right? And then it doesn't even get to 2 seconds because at 2 seconds you would get negative 3 meters because you keep subtracting 6. So notice that, anyway, these circles, they don't continue. It should just go less than 2 seconds. But yeah, okay. So now we want to find dA dt. So what do? We say A equals pi r squared. Now we're going to take d dt, my bad, wrong color. D dt on both sides. Now, this will become dA dt equals, now what is the derivative of pi r squared? It is 2 pi r dr dt. And if you feel like I'm confused on how to do this, just shoot me an email or we'll talk in the Google Hangouts whenever you want. But for now, in the previous video, I explained this more. Yeah. So now, how do we continue? Do we know what dA dt is? No, we don't know what it is. Notice this is what we want to find. Do we know what r is? Yes. Do we know what dr dt is? Yes. So great. All we have to do is just plug in r and dr dt. This problem is easier because in the previous problem, if you remember, notice that we didn't have r. We had to find r using the equation of the area of a circle. Here, we already have all the information we need, so we just plug it in. So dA dt is equal to 2 times pi times, what's the radius? 9 times negative 6, like this. Okay? So now once we actually multiply these numbers across, dA dt equals, all right, let me get my handy dandy calculator. Let's see, so let's clear 2 pi times 9 times -6. Now, if you don't have a calculator with you at home, just go on to some, type in calculator into Google, and I'm sure you can get something. Hit enter, and now we have equals, let's write this number down. It is -339.2920066. Okay, now let's just be very careful. We're not just done yet with this number. What is it saying? What does this solution mean in context of the problem? It's saying every second the area is decreasing, and don't you remember we have to round it. So let's round this number to 3 significant digits, so 339.292. Now, how would you actually finish this off? Notice it has to be meters squared per minute. Okay, if you just write meters per minute, it's slightly incorrect, because notice that when you have area, in area you have to have it in terms of some units squared, because you're in the next video I'll try and explain this a little bit better, but you have to have it in this format. Okay, that's it. So let's see, for the next video, what am I gonna do for the next one? Let's see. Question number 3, I'll pause this video and I'll try and do this question in the next video, but imagine if you have a sphere. What are you gonna do for this one? Okay, I'll see you in the next video.